Hello friends, in this new video we will see what is a partial differential equation and how the partial differential equations forms. The definition of partial differential equation is similar to an ordinary differential equation. Here the difference is only about the derivatives. The partial differential equation dependent variable is a function of more than two or more than two variables. Therefore, here there are two or more than two independent variables. And therefore, the definition of partial differential equation is are those equations partial differential equations partial differential equations those are those equations which contains which contain partial coefficients partial differential coefficient. This means partial derivatives. Since the dependent variable is depend on two or more variable, we do not have a total derivative, and that means ordinary derivative. The derivative is a partial, so which contain partial derivatives: independent variable and dependent variable dependent variable dependent variable. Okay, so this is the partial differential equations. That means del z by del x plus del z by del y equal to 0. This is the simple partial differential equation. Here z is a dependent variable, x and y are independent variable. Similarly, del 2z by del x square plus 3 into del 2z by del x del y plus del 2z by del y square equal to 0. This is the second partial differential equation. Or we have a simple del 3z by del x cube equal to 0. This is also a partial differential equation. Now look at the order of the derivatives. Here order of the derivatives is 3. Here order of the derivative is 1. Order of derivative is 2. Now sometimes we have del 2z by del x square plus del z by del y plus 5 equal to 0. This is also a differential equation, and here the highest derivative is 2. So the highest derivative in the given equation is called as the order of the differential equation. So what is order? Order of a partial differential equation is same as the order of the highest derivative in that differential coefficient in that equation. So this is about the definition of partial differential equation. Now we see how these partial differential equations forms. There are two methods of forming a partial differential equation. First method is elimination of arbitrary constants. By eliminating arbitrary constant, arbitrary constant. This is one method, and second method by eliminating arbitrary function. These are the two methods of formation of partial differential equation. Let us consider x square plus y square plus z minus c whole square equal to a square. You can see that here we are always taking z as an independent variable, x and y as a z as a dependent variable, and x and y as an independent variable. You can see that this equation contains two arbitrary constants c and a. We have to eliminate this arbitrary constant. To do that, we differentiate this with respect to x and y. So differentiate, let us call it as equation number 1. Now differentiating with respect to x partially. Now remember that when we differentiate with respect to x, as y is an independent variable, we treat this y as a constant, and therefore derivative of constant is 0. Derivative of x square is a 2x. Derivative of y square, y is a independent variable, so its derivative with respect to x is 0. Z is a dependent variable, so its derivative 2 into z minus c into del z by del x equal to a square is a constant, its derivative is 0. Now here we introduce a new symbol del z by del x equal to p, and hence we write it as, here you can see that we can take 2 common and cancel, so x plus z minus c into p equal to 0. From this we can calculate z minus c equal to minus x divided by p. Okay, so this is obtained by differentiating with respect to x. Now differentiating partially with respect to y partially. Derivative is partial in the partial differential equation. So when we differentiate with respect to y, derivative of x is 0. Remember this thing. Plus derivative of y is 2y plus derivative of this 2 into z minus c into del z by del y equal to 0. Likewise here del z by del y, we use this symbol as a small q. These are the two notations we are frequently using while studying this paper. Now again 2 common and cancel, we have y plus z minus c into q equal to 0. Again z minus c equal to minus y divided by q. Okay, so from these two values we can see that minus x divided by p equal to minus y divided by q. So minus minus become plus, and we get xq equal to py, or xq minus py equal to 0. This is the differential equation which we have obtained by eliminating two arbitrary constants x and c and a. Okay, similarly you can see that we can eliminate an arbitrary function. So let us see that example, how to eliminate an arbitrary function from this, and how we get different partial differential equation. So let us consider an example, z equal to f of x square minus y square. Here f is an arbitrary functions, z is dependent variable, x and y are independent variables. Now differentiating with respect to x partially. So when we differentiate with respect to x, derivative is a partial. del z by del x. Derivative of f, we denote it as f dash, x square minus y square into derivative of x square 2 minus derivative of y square with respect to x is 0, and no need to write. Okay, here for this we use the symbol p, 2x into f dash of x square minus y square. Okay, or p divided by 2x equal to f dash of x square minus y square. Now friends, similarly differentiate this with respect to y. Then del z by del y equal to, again derivative of f with respect to y is f dash, x square minus y square into derivative of x square is 0, so minus 2 into y. This is a q equal to minus 2y into f dash of x square minus y square, or q divided by 2y with minus sign equal to f dash of x square minus y square. Then here put this value, p divided by 2x equal to minus q divided by 2y. From this 2 get cancel, and we get py equal to minus qx, or py plus qx equal to 0. This is the partial differential equation which we have obtained by eliminating an arbitrary function. Okay, so let us see one more example to get the idea clear. Suppose we have an equation z equal to x plus a into y plus b. Now friend, in this equation we have two constants a and b. We have to eliminate these terms by differentiating with respect to x and y. So when differentiate with respect to x, we have partial derivative of x. This is a constant term, both y and b, and it is in the multiplication, so it remain as it is, and derivative of x is 1. So we get here p equal to y plus b. Now again differentiate with respect to y, so del z by del y equal to, x is constant, a is constant, and both are in the multiplication, therefore it remain as it is, and derivative of y is with respect to y is 1. Value of this is p equal to x plus a. Now z equal to x plus a is p, this is q, this is q, x plus a is a q, and y plus b is a p. So z equal to p into q. This is the differential equation which is we have obtained by eliminating an arbitrary constant a and b. So friend, I hope you have enjoyed this to find how to find an partial differential equation from two methods: elimination of an arbitrary constant, and elimination by eliminating an arbitrary function. Thank you friend, thank you for watching the